divide 2?
Yeah, and why is that? Because remember that this formula, it means we're picking 2 items. That's the number of ways to pick 2 items. And why is that the case? Because there's so-and-so number of options for the first person, and then so-and-so number of options for the second person, but we have to divide by, you know, the number of ways, because, you know, you have to divide by 2 because it doesn't matter which one comes first.
So we don't need a stick?
No, in this case we don't need a stick. The sticks are, that's another type of problem, but that's like where they're the same item in between the sticks. And so that's where you, in the stars and bars problems, which is what that's called, it's like the key is to recognize that you need to add the divider number to the number of like circles. So it's the key is to say, okay, these are just like, because normally you say, oh, okay, like divide these with 2 sticks, right? But most people, they don't think, oh, well, I can just call the stick one type of item and then the circle another type. So I can just call this B and A. Which means that you don't have 4 items, you have 6 items.
Ah.
If you don't get it, that's like the trick of that problem. And so for this one, all right, so we took team 1. We got 2 people on team 1. Now we need team 2. We have 6 people left because we already picked team 1. Who's going on team 2? 6?
15?
Yes. Why?
6 times 5 divide 2.
Yes. Okay. All right, who's going on team 3? We have 4. We need 2 more people.
6.
4
6.
times 3 divide 2.
Yeah, 4 choose 2. All right, and then team 4. There's 2 people left. They go on team 4. Okay, so now, okay, we have the answer to that. So let's say, for example, A really likes B. A wants to be on the same team as B.
Oh my god.
Because A likes B, okay? And A is like really hoping, he's like, well, maybe I get lucky and I'm on B's team. Okay? What is the probability that A and B end up on the same team?
21.
Probability.
Probability. Okay.
What's on the bottom?
B choose 2
Times.
6 choose 2
Yeah.
times
Wow.
4 choose 2.
Yeah. What's on the top? Yeah.
Answer is A choose 2 1. No?
This is a little bit hard. I'm gonna give you a hint. So, how many possible teams can A and B be on? There's 4 teams, right? So we want to count the number of arrangements with A and B on the same team. Right?
So we fixed A and B at the
Yeah, so you know, like we say, okay, A and B are on the same team, right? How many teams can they be on? Okay. Put A and B on the same team.
Yes. And then we should make about more 3 group.
He choose to times 4 choose to.
Let me confirm. Because, yeah, that's accounting for all possibilities. Because we're not saying, the way that I said, it's not that the teams are different. So, they just need to be on the team together. So it doesn't matter if we pick them first and we just set A and B. Yeah. Yep. I think that's right. 그냥 확인 해야 돼. 못하면서 생각했는데 괜찮아요. 근데 내가 틀면 알려주세요.
But we don't know too.
근데 알 수 있어. You can know. I make mistakes too. You know, it's like I'm not perfect, so I sometimes make mistakes or I write something stupid. When I was doing 15 times 6 earlier, I wrote 75 instead of 19. So I can be wrong sometimes, but I think that's right because that would be like 150. Yeah, that's about right. Cool. All right. So we got that. All right. How many ways can we make 2 teams of 3 and 1 team of 2? No, it's so easy. It's so easy. 너무 쉬워요.
Really?
Yes. Just think what you did last time, okay? You can do it easily. Based on the last problem.
To solve the possibility. The probability.
No probability yet. Just figure out the bottom part. So just figure out, all right, 2 teams of 3 and 1 team of 2. And you don't have to solve it. Just write it in the form. Well, technically it's right, but this is 1 and this is 1.
Oh, 그러네.
You just said plug 1, it's right, but let me think for a second. 2 teams of 3.
8 choose 3 times 5 choose 3 times 2 choose 2.
I have to think for a
What?
sec.
2 choose 2
Yes.
and
Wait a second.
And then
Hold on. I have to think.
8 choose 3 times 5 choose 3.
Because is that the same? Because you could pick the 2 first, so I have to check it.
두명 들어간 게 한 개.
Well, it cannot be swap.
Huh?
This one can be swap.
Swap?
Yes, change.
스위치?
So we take, okay, 2 teams of 3, 1 team of 2. Alright, so we take 3 people, or, it should be the same though, so it should be the same if we take 2 or take 3 first. Okay, cool. Alright, so this needs to be the same as, yeah, it's right, I think. I think it's right. I think it's right. Give me a sec.
Usually 6 choose 3. Because you forced pick 2. Second one is
Either one, right? I think it's the same because it just depends on what we have. No. Something's wrong. Something's wrong. I have to find out what's wrong. Why is it wrong? Why did I mess this up? Okay.
I think you should write about 8 choose 2 times 6 choose 3 and times 3 choose 3.
Ah,
yes, that's
thank you. Yes, see, I'm being dumb and I'm really right. Okay. Yes, we are right. That is good.
Yay!
See, I was a bit confused. I'm confused sometimes too. So
That's okay.
I'm like, the theory is right. The theory is right. Do you see why the theory is right? Like, do you see why the method was right? Why is the method right? Why is this the same? Why is this the same? Why are we doing the same thing here?
how can I explain?
그니까.
설명해 보세요. 한국어로 괜찮아.
아. 그니까.
한국어를 못하네. 우리는.
한국어라고.
Choose 2 team of 3 first, or choose 2 team of 2 first is same.
Why?
Oh.
Because the way that we've set it up in the problem is it doesn't matter which team you're picking first. It doesn't matter. Okay? It's like, oh, well, okay. You know, we can pick the team of 2 first.
Yes.
But we're covering all possible ways. Every possible way to pick the team of 2. Right? And then we have every possible way to pick the next team of 3. Every possible way to pick which is just 1 because there's only 3 people left. Now, in this case, every possible way to pick the first, like the team of 3. Every possible way to pick the next team of 3. And then there's 2 people left. Which is every possible way. So in each case, we're covering every possible way to pick every group.
And is it possible that we pick the one of 2 people in the middle?
Yeah.
Oh.
It doesn't matter the order that you pick them because in each case, it's covering every possible way. So as long as you are picking a total of 2 groups of 3 and 1 group of 2, you've covered every possible group of 3 and group of 2. Okay?
Okay.
Because it doesn't matter, okay? If you think about it, like, in this group, we can have A, B, C, D, E, F. You can have any combination of 2 people. Right?
Yes.
You've covered any combination of 3 people, any other combination of 3 people. This is the same. It's leaving any combination of 2 people, any combinations of 3 people. Okay? Alright. Now, I don't know, okay, this might take me a second to solve it, so I don't know if I should ask it, because it might be kind of hard for me to solve in a short period, because it's a case-by-case thing. I think it's possible. Okay. Nah, we won't do that. It's too hard.
Oh.
I was gonna ask like the probability that A and B are on the same team. But I think it might be kind of hard because you have to do the case analysis where you have to consider if they're on the team of 2 or if they're on the team of 3. So it can be, that's a little bit too hard, I think. Okay. Sorry. I mean, I guess I could ask like 9 people and then the probability might be 16. Okay. No.
Okay.
We don't do that today. Okay. Okay. Let's think of another. I want to do like one more problem like this, and then we can talk a little about conditional probability more because I have some problems I want to do with that after a break. Okay. So, let's see.
And it is not conditional probability.
Not yet.
Oh, really?
We will.
And it is a pigeon or principle we.
So I just taught you that because of the car thing. But that can be used in similar type of problems. So there's a interesting birthday question that has like probability and pigeonhole principle.
Birthday?
Yeah. Where it's like, okay. Like you can talk about, like there's a probability question to do with birthdays and it's like kind of hard. But it's like the probability that if you're in a room with like 20 people, it's like the probability that someone has the same birthday as you is more than a half. Which seems kind of weird, right? Because like, if you think about it, how many days are there in a year?
365.
About, yeah. 365. 365.
Yes, okay.
Yeah, yes. So, if you think about it, if you have 366 people in the room, does someone have the same birthday as you? What's the chance that someone has the same birthday as you?
1.
Yeah, it's 100%. Someone has to. Why?
Because 1 year is 365 days. Oh.
That's that thing.
Mm-hmm.
Okay? That's how you can use that. There is a really hard problem that I wrote like on the problem set when I TA'd this course a couple years ago. That was like to do with this, but it was really hard. And I won't give that. I can find some easier questions with the pigeonhole principle. But yeah. Okay. So you usually use this when you're doing proofs and you want to prove that like there's at least a certain amount of something in somewhere. So it's usually used like, for example, if I said like, you know, I have 10 people and I'm splitting them into 3 teams. Prove that one team must have more than 3 members. At least one team must have more than 3 members. Ten people. They're going into groups 1, 2, and 3. One of these has to have more than three members if everyone goes in a group. Why? Okay. Let's consider the cases. We know there has to be at least one person per team, right? Okay, we've established that. So, if one team has one person, how many are we splitting between, like, okay. So, basically we want the least number of people on every team. Okay? So, what's the best way to do that? Alright, we're going to split them all up to begin with. So we're going to put one person on this team, the next one on this team, the next one on this team. Okay? Alright, well, let's do that again. We've got 4 people left. And we have 3 teams, each with 2 people. Okay, it's the same. 4 pigeons. 4 pigeons and 3 holes. What has to happen to one of the holes?
Each team has at least one people.
Yeah, so each team has at least 1 people, at least 1 person. I mean, it doesn't matter. We could say a team could have 0 people and it's still the same problem. It's still the same result. It's that there exists. So this is how we write there exists. Do you know this symbol yet?
Mm-hmm.
Okay, this means that there exists. And what does that mean? That means there is. It exists. 있어요.
Yes.
Like there's at least one, you know? At least one. So there exists there exists a team with at least, like, more than, strictly more than. So more than 3 people. And this is how you're going to use this thing.
It is more.
Yep.
This.
If you have 10 people, not 8, that was the last problem. 10 people in 3 teams. One of those teams has to have more than 3 people. Prove it, convince me. Why?
Oh my god.
we're putting the pigeons in the boxes.
Oh.
It's the same thing. We're putting 10 pigeons into 3 boxes, into 3 holes.
Oh.
Okay? 10 people into 3 teams.
If we can divide the 3, it would be more than 3.
Yeah, but no, convince me. Why? Why? Like, cause the teams don't have to be equal amount of people. So that doesn't convince me because if you think about it, you know, teams 1 and 2 could have 1 person. But then how many does team 3 have?
8.
Yeah. So I want you to think about it like, alright. So think about it as like, I filled them all up. I put 2 people on each team. I'm trying to separate them equally. Now, on the last round, right? So I'm like, okay, I'll put them on different teams because that's my best possible option. Because we know that if I have 1 person on one team, you know, and then 1 person on the next, it's no good. So that's bad. What about 1 and 2? 7. What about 2 and 2? 6. No good. No good. None of it's good. Alright? So we know that we have 2, 2, 2. We gotta put the third ones. And then we have 4 left. 4 into 3 holes. Come on! Alright? We've got 4 people. We need to put them on 3 teams. Tell me, why do 2 people have to go on 1 team?
Do the 4 people go to the team equally?
We can do whatever we want with them.
So we have a 4 birds and 3 holes.
Yes, yes. This is the thing is, it seems obvious, but when you do a proof, you need to prove to me. You need to tell me why. Like it needs to be perfect.
Because each 1 bird into those 3 holes, but 1 bird is left, so 1 bird should go to the other 1 box. So 1 bird, and 2 birds.
Yeah, and we already had 2 in each one. What's 2 plus 2?
4.
Yeah, one of them has to have 4. So by the pigeonhole principle, you can say that. That's how you can use that in proving things. Okay? You heard so?
Yes.
Sorry, I know it's so stupid. It's so stupid, right? Like it's so easy. It's so easy and it's so obvious. But when you do the proof, you need to use like evidence. You can't just be like, well, it is because it is. Because it is. That's like the first lecture in the course is like, proof by intimidation. It's right because I'm right. What is it? That's what people love to do. They like to say, it's right because I'm right. 내가 맞아서? 맞아요. Actually, it's funny because there's a story where a famous mathematician, he wrote in his like book, he had a theorem, right? And he knew it was true, and he wrote proof. Trivial. You know what trivial means? So it means it's so easy you don't have to do it. It's super easy. He writes trivial, but it took centuries, hundreds of years, like 200, 300 years for anybody to prove it. So why? So he was wrong. It's not trivial. And the proof, it was like a book. Okay. So now I want us to talk about conditional probability a little bit. Because we started that last week, but we had to talk about some other things first because I wanted to get the basic counting rules out of the way. Alright, so we have our Bayes rule. This is called Bayes rule.
We learned that until now it's not a conditional probability.
Not quite. No, because right now what we've been doing is I've been asking you like, oh, okay, we've got a deck of cards. What's the probability we pick two of the same number? Or we have people in teams. What's the probability that we, A and B end up together on the team of two?
What we call that?
That's just regular probability.
Um,
Because there's no condition.
that's
There's only one event that we care about. It doesn't depend on other events. Now, if I had asked you, what's the probability that A and B end up on the same team given that C and D are on the same team, that would be conditional probability. If C and D are on the same team, then what's the probability that A and B? It depends because it changes things, right? Because it's probably more likely that A and B are together if C and D are together. Because A or B can't be with either C or D. Okay? This is the probability of event A given event B happens. We know event B happens. Okay, well now we're going to talk about the corona test problem.
No.
Corona 검사.
코로나.
corona 검사.
아.
음성. Yes. Okay, so we have the corona test. Let's say that your corona, if you have corona, so I know corona, I'm sorry.
COVID.
So we have two people, okay? We have two people. Okay, we have Junhee. Junhee.
Okay.
I need to say it right. And we have
은혜.
Eunhae.
Oh.
Someone else. And Eunhae, okay?
Oh yes.
Ooh.
Wow.
So if, alright, so I'm just using you guys are just people, okay?
Okay.
So anyone, it doesn't matter like which people they are, okay? So Eunhae goes to get a corona test. No, the corona test, if Eunhae has corona, let's say, sorry, 미안해요. It comes back positive. Positive, 뭔지 아세요?